Hi Calculus 1 students. In that video, I'm going to show you this limit. Not an easy limit for several reasons, but main reason is that it uses two techniques. First, we do direct substitution. It's a good practice to write d.s to indicate your reader that that's what you're doing. This also allows you to skip some steps. So what step do you skip? Well, you can do some mental math, but not too much, okay? Just enough. I'll show you. 5 minus 1 is 4. Square root of 4 is 2. Times 2, 4, okay? Don't do it all. Just do like term by term. That's the ideal. This one, 5 squared is 25. Minus 9, 16. Root of 16, also 4. Then at the bottom, 5 squared, 25. Times 2, 50. Okay, 9 times 5, 45, minus 5, 5. Okay, so we get the problematic 0 over 0. Remember that what happens when we have 0 over 0 is we want to cancel a redundant factor that's approaching 0. So what do we do? Well, we know right away that this has to be factored. But we're lucky because this polynomial happens in a limit, so it's easier to factor. We can use the factor theorem. So use factor theorem to factor this. So I'm going to put an equal sign, but what I'm doing is I'm solving for that limit, okay? Just to be really clear. And I won't write the numerator. I will focus on the denominator here for now. So what is the factor theorem allowing us to do? So since this evaluates to 0 when x is equal to 5, we know that x minus 5 is going to be a factor of that trinomial. To find the other factor, remember that the most general way is to resort to long division. But since the degree is 2, we know that this is going to be another linear factor. So what we can do is a matching game. X times what gives you 2x squared? It's x times 2x. And negative 5 times what gives you negative 5? Plus 1. You see, as simple as that. So you don't have to factor it the way you've seen it in high school, at least not in this context, because the polynomial happens in a limit and we know that it evaluates to 0. Let's now deal with the numerator. You know by now that what you want to do is to remove the roots. You want to rationalize. You want to multiply both the top and the bottom by the conjugate. Let me show you a trick. The trick comes because you know what will be the outcome, okay? You know that what you want to do is to turn this into a difference of squares. So let's write what that difference of squares looks like. It looks like 2 x minus 1 squared minus square root of x squared minus 9 squared. Even if this was a plus, you would still put a minus here, right? Because you want to turn this into a difference of squares. You know that this costs you the conjugate at the denominator. So here you go, write the conjugate. So 2 times x minus 1 in square root, minus, plus this time, because it's the conjugate, x squared minus 9. And now we're ready for some more work. I want to show you that here you have the problematic factor. So which means we don't touch the denominator, okay? So here I could put brackets just to show you that this is multiplied by this, but please don't expand anything, okay? Because what we do, the algebra we do, is always motivated by getting that problematic factor and trying to cancel with a similar problematic factor that you will find at the top. All right, well, you have here limit as x is approaching 5. So this turns, now remember you're squaring everything, right? Not just, yeah, that's it, not just the square root. It's a common mistake to just square the square root. Here you need to really square the entire term. So you're going to have 4 parentheses, like bracket, x minus 1 minus, and then same thing, you have to put it in brackets. It's a common mistake to forget that because then the negative won't distribute over all the rest. Yeah, let's write it down. So x minus 5 to x plus 1 times 2 times square root of x minus 1 plus square root of x squared minus 9. Okay. Then you need to simplify this. Okay, so you're going to have negative x squared, you're going to have 4x, and you're going to have positive 9 minus 4, which is 5. So I think we should factor a negative because of the negative x squared. So at this point, you just do some algebra to simplify the top, okay? So let's factor the negative. You'll have x squared. Now, normally you would get 4x, but since you factored out the negative, you will have negative 4x. And here you have, normally you would have plus 5, but again, since you factored the negative, you have minus 5. So this is what the tops looks like. The bottom, you're just rewriting it. X minus 5 to x plus 1 to square root of x minus 1 plus square root of x squared minus 9. Okay, now you're almost done. So you need to factor this thing. We didn't evaluate it. Hopefully we haven't done a mistake along the way. If we haven't done any mistake, then we know that this is going to give 0 because you didn't actually cancel a redundant factor yet. So you know that the top is still going to give you 0, even though it looks much different than what we had at the beginning. So you can also use the factor theorem. But just keep in mind that the factor theorem will work here only if you haven't done any mistake before. So let's use the factor theorem. So let's actually use the color green. So for this right here, we will use the factor theorem. So remember that x minus 5 is a factor. Now there's the minus in front, so be careful, right? And then what's the other factor? Well, x times what gives you x squared? Just x. And negative 5 times what gives you negative 5? So positive 1, right? X plus 1 over the rest. So that's it, x minus 5 to x plus 1 and all of this. Okay, and now finally, so you found the problematic factor both at the top and at the bottom. So now you're very happy because you can cancel these. And once you cancel these redundant factors, then you try direct substitution again. And remember, when you do direct substitution, just evaluate factor by factor. So here you're going to have 6, but don't forget about the negative. So the top becomes negative 6. Then here, 2 times 5 plus 1 gives you 11, multiplied by, now what's this? Okay, well, we know the conjugate, right? The conjugate was giving 4 minus 4. Here, since we have a plus, we're going to get 4 plus 4. And then we have to simplify this a bit, okay? One thing I wouldn't do is to multiply out the 11 with the 8 to give you 88. Like, don't do that. So here you have negative 6 over 11 times 8. And you can simplify that a little bit. So 6 over 8, you have a common factor here of 2. So negative 3 over 11 times 4. And then finally, once you're sure that you don't have any other common factor, you can multiply it out. Negative 3 over 44. I hope this video was helpful. See you in the next video.